In this video lecture, I'll talk about operationalization and psychological measurement. I'll talk about this part of the empirical cycle. How do we go from a conceptual idea, a hypothesis about constructs, to a testable prediction on things we can measure, variables that we can observe and measure. Usually, when we form a hypothesis, we specifically think about how constructs relate to one another. For example, I might think that people that are less lonely are more happy in general. But I can't really measure or observe loneliness and happiness directly. It's not really something that I can see immediately. So how do I define loneliness and happiness so that I can look statistically if there's a relationship between the two? This is called operationalization. Now, operationalization means that we define constructs into variables that we can actually measure, that we can use in quantitative analysis. So we operationalize these constructs as variables. And for example, we could operationalize happiness as your score on a scale designed to measure happiness. And we could operationalize loneliness as the time you spend alone, for example, or also your score on some other scale defined to measure loneliness. We can distinguish between different types of variables. A variable is a quantitative variable that we can use in analysis. We have outcome variables and predictive variables. The outcome variable is a thing we're trying to explain. In this case, we think that loneliness causes happiness, so then happiness is the outcome variable. We want to see how does loneliness impact happiness, and especially if we could somehow intervene on loneliness, which is hard to do, okay? And how did that impact happiness? In this case, loneliness is then what we call a predictor variable, the variable that we use to predict what happens in happiness. If you use an experimental design, so an experimental design is a setting in which we actually vary these variables ourselves, right? So maybe we assign people to a condition with some treatment designed to make them less lonely, right? Maybe we let some people do a camp and other people a waitlist condition. And then we see what the impact then is on the outcome variable. In this case, we can also use these terms dependent variable and independent variable, which you might have seen before already. Often these are actually used with interchangeably. You'll sometimes see the terms dependent variable and independent variable used in a correlational setting rather than experimental design. And you might also see outcome and predictor variable used in experimental design. But in general, this is the terms that we'll use. We can define different types of variables. A nominal variable is a variable that has only categories. For example, group membership or country of origin. And something we can't really order. We could theoretically assign a number to that. We could say, okay, people that are from the Netherlands are a 1, and people that are from Germany are a 2, and people that are from England are a 3, people that are from Singapore are a 4, for example. But there's no meaning to these numbers. It's not like if you're in Germany and you score rated at 2, and that's better than being from the Netherlands, which is rated at 1. Okay. We can't order these anyway. An ordinal variable, which is also termed ordered categorical often, is a variable that can be ordered. So in this case, we can still assign numbers, and the numbers actually mean something. For example, how severe is your symptom? Let's say 0 is I never experience depressed mood. 1 is I sometimes experience depressed mood. 2 is I often experience depressed mood. In this case, we can order the categories because never is less than sometimes. But it's not like we can really say anything else about it. Not like experiencing less depressed mood is half the amount of depressed mood you experience compared to experiencing a lot. We can't really think of it in that term. We only know the order, like one is higher than the other. But we can't really say anything about the distances between the variables, between the categories. A scale variable is a variable in which the numbers can actually be interpreted. A scale variable means that we measure something, right? And if we see a distance between, let's say, 1 and 2 and 3, then that distance is the same at each of these points. There are two types of scale variables. We have the interval scale In that case, the differences between two numbers can be interpreted, but there's no 0 point. So Celsius, temperature Celsius is a really good example of this. For example, is because you have 0 degrees Celsius, but it's not really meaningful except for the point where water freezes, right? Means that if it is 5 degrees or 10 degrees, it's not twice as hot if it's 10 degrees compared if it's 5 degrees. That's not how temperature works, unless you really go on the Kelvin scale, right? If it's 20 degrees compared to 10 degrees, it's not twice as hot as compared to 10 degrees, right? So the 0 point is not interpretable in that sense. If we have an interpretable 0 point, like for example temperature in Kelvin, where you have an absolute 0 point, or height, where basically something can be so small and it cannot be negative, then we can call it a ratio scale. A ratio scale we can use if the 0 point is also interpretable. On an interval scale, I can only interpret differences. Let's say a difference of 5 points between 0 and 5 degrees Celsius and 5 and 10 degrees Celsius is the same. But on a ratio scale, I can also interpret proportions. Meaning that if someone is 1 meter high, then that person is half the size as a person that's 2 meters high. In addition to these categorizations, which you see a lot, like so these symbols here are used in JASP, and you need to actually define them and define a variable, what it is, before you can use it. In addition to these, we can also define a variable as discrete or continuous. A variable that's discrete can typically take a limited number of outcomes, and a variable that's continuous can take any number of outcomes. As for example, height is a continuous variable, can be any number, but let's say country of origin is a discrete variable because it can only have certain countries. There are only so many countries that you can come from, for example. And there's some overlap in between, where it's not really clear something is discrete or continuous. Now, it is pretty important what type of variable you have, or what type of calculations you can actually meaningfully do with a variable. So you can only sum, subtract, or average variables. That means you take the average, take the mean, if they're at least measured on an interval scale. If that's not the case, it doesn't make sense to take an average. It doesn't make sense to take an average of an ordinal variable, because you have categories that are not really orderable. Like let's say, if I have a depression scale, like 0 is no symptoms, 1 is some, and 2 is a lot. Yeah, what's the average of 0, 1, and 2? So over 2 days, for example, the temperature of 29 degrees and 30 degrees, we can interpret the average temperature of 29.5. That makes sense. It's something we can do. In this case, we have to add some numbers, divide by 2 to get that 29.5. But let's say we have this response here. This is an example from the Beck's depression inventory. So the question is on sadness. 0, I do not feel sad. 1, I feel sad. 2, I am sad all the time and I can't snap out of it. And 3, I am so sad and happy that I can't stand it. So what's the average here, for example, between 1 and 2? Like let's say what would be an average of 1.5? Somewhere in between I feel sad and I'm sad all the time and can't snap out of it. It doesn't really make sense to interpret it that way. In addition, we can only interpret ratios and multiples of a variable if they're measured at least on a ratio scale. Right? If there's an actual 0 point. So a day in which it's 30 degrees Celsius is not twice as hot as a day in which it is 15 degrees Celsius. And in this case, is a person that responds at 2 on the sadness item twice as sad as a person that responds 1? That's very unclear, right? Can't really say that. Now here's actually a bit of a tricky thing. If you really think about it, like every textbook will tell you this: interval scale, ordinal scale, nominal scale. You'll learn about this. You learned about this before probably. You see it in the software. If you really think about it though, especially in psychology, many measures actually are theoretically ordinal. And ordinal variables are typically pretty hard to deal with. Like if you have interval or ratio scale, we could take an average, compare the average between two groups, t-test for example, and then you can deal with it. An ordinal variable, it's much harder to work with. You need more complicated analysis that might not be available for the type of data that you have. So quite commonly, we actually make a simplification. quite commonly, discrete variables are actually treated as continuous. So for example, this variable is discrete. It only has 4 possible outcomes. But if we treat it as continuous, we can still meaningfully use it. Also, usually, ordinal variables are actually quite often treated as interval scale variables. Again, for example, this item that we had here, it's clearly an ordinal variable, if you really think about it, a discrete ordinal variable. But this is part of a questionnaire where the total sum score is just taken by summing off all these items, and summing 0, 1, 2, and 3. And that sum score is interpreted and used in analysis. Technically, not sure if it makes sense to do that, but in practice it works out pretty useful, and we can do things with it. We can, for example, define a cutoff score for clinical depression. Both of these simplifications are not uncontroversial, and that's something that I do want to share and elaborate on. So you can argue that this is maybe not good to do in some cases, and that you should use a different analysis that is more suitable for your data. Now, if you want to make simplification like this, you want to treat your discrete variables as continuous, it helps if you just have a lot of levels, right? So in the previous question, you have 4. If you have like 7 or 8 or 9, it's already a bit more continuous than it otherwise would be. So that definitely would help. So that's also why many people don't use these items with only 4 outcomes, but rather the sum scores over multiple items, because it's a bit more continuous. And in addition, you can look at reliability, constructability, but I'll talk about that later in this course. So if you want to know more for other perspectives, you can look at the course if you're studying at the US. Psychometrics, circular equation modeling, actually, the whole field of psychometrics is really aimed to study these types of problems and how do we model also this type of data where we might not have continuous variables. Okay, that's it for this video.